Hello, this is Patrick Holberg, professor at Kalamazoo College. Today I just want to talk a little bit about why nations trade with each other. Like why, how come the two countries benefit from trading with each other, and why do they do that? Well, it turns out that the main reason for trade between nations is a difference in the relative price of goods, or in other words, a difference in opportunity cost. So this short lecture will give an overview of why the relative price is different across countries. But first of all, I want to assume a perfect world. So we're assuming here that we have perfectly competitive markets, both the input and the output market is perfectly competitive, and there are no other market failures at all. So, we have many buyers, many sellers, free entry and exit, perfect information, everything that you have heard from before. So now, if we first look at the consumer side. So when we think about consumers, there are many, many consumers, but they're all the same. So we can think of this representative consumer that maximizes utility given a budget constraint. So this is like if we're putting math behind it, this is the way we would be looking at it, right? So you maximize utility, and in this case, utility depends on the consumption of two goods. The X good, which is the one we're going to be focusing on, and it's O good, which represents all other goods. And this choice of what to do depends on the budget constraint. So how much money do you spend on the X good? How much money do you spend on the O good? And what is your income level? If we put those into a graphical display, you can see that the budget constraint is a straight line here. And if you spend all your money on the O good, then you're going to buy I divided by PO units of O. And if you spend all your money on the X good, you will buy I divided by PX. And the slope of this budget constraint is going to be the relative price. So PX divided by PO is the slope of the budget constraint. The utility is represented by these indifference curves. And there are many, many indifference curves. And, the farther away you get from the beginning here, the higher is your utility level. So clearly we can see that the optimal consumption choice will be where the budget constraints touches the highest or the greatest utility measuring indifference curve. So it's going to be some tangency there. And what we have here is that the slope of the budget constraint, which again is PX divided by PO, will be equal to the slope of the difference curve, which is what we call the marginal rate of substitution. It would just be the marginal utility of the X good divided by the marginal utility of the O good. But we don't want to spend too much on these things right now. But one thing that I want to be emphasizing is that this point, the point on the the optimal consumption point here depends on depends definitely on the preferences. So if these indifference curves look differently, it would be on a different place on this budget constraint. It also depends on the relative price. If the relative price is different, it will have either a steeper slope or a flatter slope. In particular, if the relative price were to change, so for example, if I were to draw suppose that the price of X was decreased, well then you could buy more of the X good, and then you would be able to reach a higher level of utility, and therefore we could have seen here that you would end up probably buying more of the X good. So the point here being is, as the relative price changes, your demand for the X good will change as well. And that's something that I want you to spend a little bit of time on. Now, to make it a little more concrete, we could actually solve this problem mathematically. We could consider an actual utility function. So if I were to say that the utility function is a Cobb-Douglas. So the x to the power of 1/2, o to the power of 1/2, that product gives us utility. And then they're still subject to this budget constraint. And in fact, if you're going to actually plot the budget constraint, you write it like this instead. But if we use what's called the substitution method to solve this calculus problem, this constraint maximization problem here, then we just substitute for O into the utility function, and then we can just go ahead and take the derivative. So, you know, I have done that, but let's put this one away, move these things away a little bit, and I just did this real quick. You can see how that would work. You might want to try it on your own a little bit later. But if I took the derivative of the utility with respect to x, so we take the derivative, we're going to set that derivative equal to 0. We have to use the product rule here, so you know, if you can carefully go through what happens. So I took the derivative of the first term, 1/2 times x to the power of minus 1/2 times the second term, and then I took the derivative of the second term, which has an inside, so I have to do that as well, and then multiply by the first term there. And if I just go through this, you know, I go move them over, because it's a negative sign there, I can move it over to the other side, and it becomes a positive sign. And then just manipulate these a little bit, and what we get down to is that x, the amount of x that will maximize utility, will depend on the income level and the price of x. An interesting thing about the Cobb-Douglas is that you can see that the demand for x is independent of the price of good O. So therefore we can easily see that, you know, if the price of x decreases, if this one decreases, obviously the number of units of x will increase. So they are inversely related like this. If I were to look at this diagram over here, you can see what would happen if we reduced the price of x. So here I'm having you know, the price of x decreases, which shifts out the budget constraint further and further out, and every time our optimal consumption point will be given by the new slope, the relative price. The new relative price is tangent to a higher indifference curve, and it gives us that as the price of x falls, we buy more and more and more of the x good. Now, obviously, we could plot that if we wanted to. If I were to plot the relative price of x against the amount of x that this representative consumer wants to purchase. So when the price is pretty low, they want to buy a low amount of x. As the price falls, they want to buy more x. The price falls even farther, they want to buy even more x. So what we have here is, of course, what you know as the demand curve. So we can trace out the demand curve from the constraint optimization, the utility maximization problem. And so this is something I just wanted to show you. This is where the demand curve comes from. And obviously, you know, if we had played around with, in particular, if if preferences had been different, so the utility function had been different, well then you can imagine that a demand curve could have looked very different as well. But that's not, you know, that's not what we want to focus on right now. But depending on the indifference curve, the demand curve will look different as well. So I'll just get rid of that. What I want to do next, though, is after we looked at consumers, we should look at the producer, the production side of it. So again, with a perfect world here, we have many producers. And these producers will choose an optimal level of production of two goods in order to maximize their profits. And here I have it in the short run. So we're thinking about capital being a fixed input and labor is being variable. So you can change labor, but you cannot change capital. And the first thing we would have then is, you know, we have these production functions here. I'll move these, we make it a little bit bigger here. So you can see that when we produce X, it's a function of how much capital you have and how many workers is in the X industry. And when you produce O, a function of capital used in the O industry and the number of workers in the O industry. And obviously, if you add up all the workers in the X industry and the O industry, we'll have all the workers being employed here. And the most important thing about these production functions is that we would assume that they satisfy diminishing returns. And if they do, then you know that the production function is going to look something like this. And what we have here is that, if you find the slope of this production function, that's going to give us the marginal product of labor in this case, the X industry. So the production functions are very important because it gives us the marginal product of labor, which is going to be important to us in a short while here. But if I get rid of this one, well, first of all, I want to tell you that clearly this was the X industry, but there will be another one that looks exactly like this for the O industry. So there are two production functions, and if we take these two production functions and we combine that with the labor constraint, so this, stay with me here a little bit because this one's a little bit complicated. So here's we have the production function for the X. So you can see that was the production function for X, and then we had the production function for O here. Again, two production functions that shows diminishing returns. Then we have our labor constraint, because the workers will have to work in will work in one of these two industries, and if they leave the O industry, they will go into the X industry and vice versa. And what I've done here is that if all the workers are in the O industry, then the production function will tell us how many units of O we'll be producing, and that will be 1 point. And obviously, if all workers are in the O industry, there will be 0 workers in the X industry, so we don't produce any X, so we'll be right here. That will be 1 point. That is a possible production point. Again, if all the workers were in the X industry instead, the production function for the X will give us how many units of X will be produced. Another point that is possible, and I can pick any point on this labor constraint. Here I picked one here. You can see this is how many O goods will be produced. This will be how many X goods will be produced, and put the number of O and X goods together, and that will be another possibility for production. And just the kind of language I'm using here, you can see that what we are doing is tracing out the production possibilities frontier. So this is the PPF that you are so familiar with. I don't want to go into any details here, but you can see that the slope of the production function is the marginal product of labor for the X, or well, actually sorry. Well, let's just move these away. We don't need them anymore. So the marginal product of the slope of the production function is the marginal product of labor. If we had a functional form here, you can see how we would actually find that. If there was Cobb-Douglas production, you can see that the marginal product of labor of X will just be as shown in this equation here. Again, that's not really what we are very interested in, but what we are interested in is in the slope of the PPF, the slope of the production possibilities frontier. And as you probably remember, the slope of the PPF is the marginal rate of technical substitution, sometimes called the marginal rate of transformation. It's going to be the ratio of the marginal product of labor in one industry over another industry. And the way I drew it, it will be the marginal product of labor in the O industry divided by the marginal product of labor in the X industry. And what this gives us is the opportunity cost of X. That is, if you produce one more unit of X, that is, if you add one more worker to the production of X, of course that worker will come from the O industry, so you could be moving down this labor constraint. And when you take that worker away from the O industry, you will reduce output in the O industry by the marginal product of labor in the O industry. So when we produce one more X, we will have to give up this number. This ratio will give us the number of O goods that will be given up. So that's the opportunity cost. And then you remember, of course, that the opportunity cost of doing one more thing is the same as the marginal cost of producing a particular good, because the real cost of something is the opportunity cost, and that's actually the supply curve. So what we have done here, if we were to, well, let me just be a little bit more careful about it. So if we go back to this one here, if I were to, you can see here's a relative price, so this will be px divided by po. If I were to say increase the relative price, you can see that this one will get steeper. If I increase it even more, it gets steeper and steeper, and every time you can see that we'll be increasing the number of x units of x that we'll be producing. So when the price of x increases relative to the price of O, firms would choose, in order to maximize profits, to produce more of the x good. Okay, let me just get rid of these things here to then show you that if we were to trace these things out, so here you can see that I increased the price of x from x1, px1, px2, px3, and every time the firms, the representative firm, want to produce more and more of the good x. And if I trace that out, you'll have this line here, which is the opportunity cost, the marginal cost, or in the end, the supply curve. Alright, so we have consumers giving us a demand curve, producers giving us a supply curve. If we put those things together, what will we have? Well, of course you know what this is. So if we put those two things together, what we have is a demand and supply framework. And here we have the one I derived here. This is country A. And the way I drew it, you can see that the equilibrium in country A will give us a relative price that is PXPO A. But if we had another country that has either different preferences, and if you remember, if you had different preferences, that will give us a demand curve that looks differently. Or if you had different technology or a different amount of resources, that would give us different opportunity costs or different marginal costs or a different supply curve. And if we had this different country, their equilibrium will be different. It will be right here. And their relative price will be different because of different preferences, technology, resources, what have you. And now we actually have come to the conclusion of this one, because you can see that these two differences in relative prices gives us an opportunity for both countries to benefit from trade. So, you know, we could, if I were to draw how that would look like, well, when they start trading with each other, you know, one country will export good. Of course, the exporter will be the one that has a relatively low relative price of X, and the import will be the one with a relatively high price. And what we'll have that there will be a terms of trade in between the two countries' relative prices that will determine how much will be imported and how much will be exported between these two countries. And from here, we can then start doing various things if we wanted to. I'm not going to do that in this video. We could do welfare analysis to see if both countries are actually better off from trade compared to if they do not trade with each other. Alright, so here we have it. This is the main reason for why countries trade with each other. They have different relative prices for these various goods. And the reason the prices are different is because consumers make choices optimally based on their preferences and their budget constraint, and producers make choices optimally based on their level of technology and availability of resources. Preferences, budget constraint, technology and resources gives us demand curves and supply curves that will look different in different countries because they have different preferences, technology, and resources. And those differences then gives us different relative prices which then gives us a reason to trade with each other. Thank you very much.